So welcome, this is CI May June 2020 060607 paper 6 version 63. We shall try to solve the question now. The first question is investigation, question 1 to 6 about digital roots. You are advised to spend no more than 15 minutes on this project. This investigation is about digital roots of positive integers. What is the meaning of a digital root? A digital root of a positive integer add its digits and if necessary the digits of the resulting number so that it will end up in a single digit. So for 7 it is directly 7. For 23 you have to add 2 and 3. For 78 you add 7 and 8 you get 15. For 15 again you add 1 and 5 you get 6. For 199 add 199 you get 19. Then again add 1 and 9 you get 10. Then again add 1 and 0 you get 1. So what is the digital root of 2067? 2 plus 0 plus 6 plus 7, which is 15. Again add 1 and 5, so which is going to be 6. The digital root of 295 is 7. What is this can be written as d of 295 equal to 7. Find d of 173. So 1 plus 7 plus 3, which is 11, which is again equal to 1 plus 1, which is equal to 2. Find a 3-digit number who is with a digital root 4. So maybe 103. You can add 1 plus 0 plus 3 is equal to 4. So answer is 103 or any other number of your choice. Write down the maximum value of a digital root of a number. So maximum value should be 9 because once it goes to 10, again it becomes 1. So what is going to be the maximum value? 9 is going to be the maximum value. Find a number greater than 9504 which will give this maximum value of digital root. 95, I want the digital root to be 9. So 95. So what am I going to do? 9 plus 5 plus question mark should give me totally 9. So as of now we can see that 9 plus 5 is nothing but what? 14. If I make it as total as 18, then 1 plus 8 is going to be nothing but what? 9. So I should be getting it out 18. So how can I get 18? So what I can do, I can replace this number with 4 and this number with 0. So it becomes 18 and its digital root is going to be 9. So answer is 1 plus 8 which is equal to 9. So my answer is 9540. You can write any other number which gives you the digital root 9. Use some of the values of x to find the relationship between digital root of x and digital root of x plus 9. So I take one example, digital root of 12, which is 3. Digital root of 12 plus 9 is nothing but 21, is also 3. One more example, digital root of 34 is 7. 34 plus 9 is 43. Its digital root is also 7. So what is the relationship that we could able to get it out? Digital root of x is equal to digital root of x plus 9. Find a relationship between digital root of x and digital root of x plus 9 power n. So same, I take digital root of 12, which is 3, digital root of 12 plus 9 power 2, because last time 9 power 1 has already been done, 9 power 2, which is 81. So 81 means 93. Digital root of 93 is 9 plus 3 is 12. Again 12 becomes 1 plus 2, which is equal to 3. You can see that they are same. We take for the other example also. Digital root of 34 is 7. Digital root of 34 plus 9 square. So 34 plus 9 square is 34 plus 81 is 115. So we can see that its digital root is 7. So we see that they are equal. So what is the relationship we got? Digital root of x is equal to digital root of x plus 9 power n. N is greater than 1. If n is 1, it was this previous one. Coming to question number 4. He has given x as 3, y as 101. Digital root of x is 9. Digital root of y is 2. Then he multiplied x and y and got a new number, found its digital root as 9. He multiplied the digital roots itself only. He got 18 and found the digital root of that answer. He got 9. So what has he done it out? First he multiplied the numbers itself. Then try to find it out the digital root of those numbers. So for here 2, 3. So it becomes 2 plus 3 plus 9 plus 4 plus 0. So it becomes 5, 14, 18. Then digital root of 18 is nothing but 9. Then he multiplied the digital roots itself only. 9 and 4, 36. Then the digital root of that product is also is going to be 9. So here what should I be doing it out? Digital root of, multiply both the numbers, 253 times 42, which is nothing but what? 10626. Now when I add it out, this one plus 0 plus 6 plus 2 plus 6, which gives me 15. Digital root of 15. So 1 plus 5 is nothing but what? 6. Now see, we have multiplied the digital roots itself only 1 and 6, 6, and digital root of 6 is 6. They are same. So what is the relationship that we got it out? If I take the digital root of the product of the numbers is equal to digital root of the product of the digital roots. Okay, so now part C. He says digital root of x square is equal to whole square of digital root of x. What does it mean? I take let x is equal to 9, or maybe 11. I take 11 square should be equal to digital root of 11 whole square. So digital root of 11 square means 121, which is 1 plus 2 plus 1, which is 4. And over here digital root of that is 11 is nothing but what? 2. So 2 square 4. Yes, it is same. But we have to try to check 4 or 5 examples. Maybe I'll be trying to check digital root of 23 square should be equal to digital root of 23 whole square. So 23 square. Take a calculator and calculate how much is 23 times 23. 23 times 23 is 529. So digital root of 529 is 5 plus 2 plus 9, which is 11 plus 5, 16. Again, digital root of 16 is nothing but what? 7. 1 plus 6 is 7. So over here, digital root of 23 is 2 plus 3 is 5. 5 square, which is 25. They are not equal. So, no, because you can write this example. Because the example is digital root of 23 square is not equal to digital root of 23 whole square. Question number 5. The diagram shows some digital root of x cube plotted against the values 1 to 10. So digital root of 1 is 1, 2 has been given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4 has been done. 5. 5 cube. 5 cube is nothing but what? 125. So what is its digital root? Digital root is 8. So 5 is 8. Okay. So 5 is 8. Next, 6. I take another as a symbol. 6. 6 cube. 6 cube is nothing but what? 216. It's going to be nothing but what? 9. Digital root of 6 cube is 9. So 9. Digital root of 6 cube is 9. So 5 was 8. So that was an error. So let me check that 8 over here. 5 was 8. Now 7 cube. 7 cube is 343. So digital root of 7 cube is 343. So it becomes 3 plus 4 is 7, 7 plus 3 is 10, 1 plus 0 is 1. So it's going to be 1. For 7 it's going to be 1. Then next I take for 8. 8 cube. So 8 cube should be equal to 512. So its digital root is going to be 8. For 8 cube, it's going to be 8. Then I take 9. Digital root of 9 cube. So 9 cube should be equal to 729. Its digital root is 11, 18. 18 means 9. Digital root of 9 cube is 9. Then finally, I take the digital root of 10. 10 cube is 1000, which is going to be 1. For 10 cube, it's going to be 1. Complete the diagram. So we have completed the diagram. Find the nth term of the sequence of digital cube of 8. Find the nth term of the sequence for x for which digital cube of x is 8. The x cube is 8. So we can see where is x cube is 8. So for this one, for 2, for 5, and for 8. The digital root is for 2, 5, and 8. So nth term. So first term is equal to 2 is equal to a. Second term is equal to 5. So common difference is equal to t2 minus t1, which is 5 minus 2, which is 3. So nth term is nothing but what? A plus n minus 1 times d, which is 2 plus n minus 1 times d. So it becomes 3n minus 1. So answer is, when you simplify, it becomes 3n minus 1. Use the digital roots to decide whether is a cube number or not. So what is the digital root of this one? 1 plus 3 plus 3 plus 1 plus 6 plus 3 plus 1 plus 3 plus 3 plus 1. So we took 1, 3, 3, 1, 6, 3, 1, 3, 3, 1. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 1 is 8, 14, 17, 18, 21, 24, 25. Digital root of 25 is again nothing but what? 7. Do we have anything a digital root 7? See, for all cube numbers, never is a digital root is 7. So it is no. No, it is not a cube. It is not a cube, as digital root is 7. No cubes have digital root as 7. So all the cubes will be having digital roots, the numbers which we have plotted on the graph. So there is no 7 at all. Question number 6. Pn is the nth prime number. The diagram shows the digital root of the prime number for the 5th prime number to the 50th prime number. Complete the first 4 prime numbers. What are the first 4 prime numbers? The first prime number is 2. So its digital root of 2 is going to be 2. Then 3. Digital root of 3 is going to be 3. 2, 3, 5, 7. Digital root of 5 is going to be 5. And digital root of 7 is going to be 7. So for 2 it is going to be 2. For 3 it's going to be 3. For 5 it's going to be 2, 3, 4, 5. For 5 it's going to be 5. For 7 it's going to be 7. This is going to be the diagram. Is it possible to use a diagram to predict the digital root of 50th one, 50th prime number? Give a reason. I think so. There is no such pattern is following it out. You can see all the numbers have been scattered, so we cannot find the digital root. So what we can say is that no, it cannot be followed as patterns are not repeated. This diagram shows the frequency of the digital root of 1200 prime numbers. Write down the two observations from the diagram about the digital roots of these prime numbers. What are the observations? We can see that the digital root 1, 2, 4, 5, 7, 8 are occurring more. So 1, 2, 4, 5, 7, 8 occurs with same frequency, almost same frequency, and 6 and 9 do not occur. You can write much more. 3 occurs very less, and so on. 4 plus some number plus 2 plus 7 is a 4 digit number which is not a prime number. Use the diagram to find the following missing digit. So we have to find it out a prime number. And what is this? What is the missing digit? So what am I going to do? For example, it is a 4, a question mark, 2 and a 7. What is this 4-digit number? So if I take 4 plus this question mark plus 2 plus 7. So it becomes how much? 4 plus 2 is 6, 6 plus 7 is 13, 13 plus question mark. It should be a prime number. It is not a prime number. It should not be a prime number. So let us try that because the last digit is 7. It is not divisible by 2. We'll try to make it to divisible by 3. In order to make it divisible by 3, sum of all the digits should be divisible by 3. So already 13 I have. So if at all I have 2 over there, then I can see that it is 15. So it will be divisible by 3. So it will not become a prime number. So the number is nothing but what? 4227. Or if I add it out instead of 2, if I add 5, then 13 plus 5 will become 18. 18 is also divisible by 3. So you can write it as 4527. So any one of the answer you can write. No need to write both the answers. That completes question number 6 and part A. Now coming to part B, modeling questions. Earthquakes. You are advised to spend no more than 50 minutes on this part. The task is about the strength and frequency of earthquakes and probability of their occurrence. The strength of an earthquake is measured in magnitudes. An increase in magnitude of 1 increases the energy released by 32 times. So the magnitude of 4.7 releases 32 times more energy than 3.7. Write down the magnitude of the earthquake that releases 32 times the energy of the magnitude of 2.5. So 2.5 plus 1, 3.5. A magnitude of 6 earthquake releases 30,000 units of energy. Calculate the number of units of energy of magnitude 7 releases. So it is 32 times 30,000. So which is 960,000. A model for the energy E that an earthquake releases is E equal to G times H to the power of 1.5 m, where G and H are constants and m is the magnitude of the earthquake. An earthquake of magnitude 6 releases 30,000 of energy. Write an equation involving G and H. So 30,000 is equal to G times H to the power of 1.5 times 6. So which will become 30,000 is equal to G times H to the power of 9. An earthquake of magnitude 8 releases 30 million units of energy. Correct to one significant figure. Find the write an equation involving G and H. So is equal to G times H to the power of 1.5 times 8. So now that becomes equal to G times H to the power of 12. Use your answers in part A and part B to find the value of H. So we have to find the value of H. So what am I going to do it out? Just correct division. So I divide part A with part B with part A. Divide with this 30,000 G H to the power of 12 upon G H to the power of 9. So we can see that 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros gets cancelled. G gets cancels. 3 times 1 and 3 times 1000. So h power 9, h power 3 equal to 1000. So h is equal to 10. What is the value of h? H is 10. What is the value of g? Substitute that one in the first equation. My first equation is 30,000 is equal to g times 10 to the power of 9. From there, g is equal to 3 times 10 to the power of 4 divided by 10 to the power of 9 will become 3 times 10 to the power of minus 5. The magnitude of the earthquake is 6.2. Calculate the number of units of energy it releases. So, the magnitude of energy is 6.2. The magnitude is 6.2. Calculate the energy it releases. So we know that E is equal to, now we got formula is G times H to the power of 1.5 to the times M. G value we got 3 times 10 to the power of minus 5. H value we got 10, 1.5 to the power of 6.2. Simplify that, we should be able to get in, we write it as in rounded figures, 60,000. So we should be able to do that with the help of the calculator and find the values always in three significant figures or the simplified value, which should be giving you as 60,000. Or if you want to write it out, it can be written as 59,587, but better write in a rounded figure. Question number 9. This table shows the information about the number of earthquakes in northern Chile between 2008 and 2018. There were total 2028 earthquakes. M is greater than 3.5. There were total of 2028 minus 1912, 116 earthquakes between 3.5 and 4. Then find the number of earthquakes between 5 and 6.5. 5 and 6.5. Where is 5 and 6.5? So we do 230 minus 3, which is 227. The model for this data is equal to n is equal to k by m, where k is a constant, n is the number of earthquakes, n is the number of earthquakes, and m is the magnitude. M is going to be the magnitude. Is it suitable model? So how do you decide? Now, for example, we take 3.5 and 2028. Number of is 2028. K is equal to k upon 3.5. So we check, we use the values of n and m from 3.5 and 2028 and get the value of k. So k value will be 2028 times 3.5, which is 7098. So I should be getting the same k value for any another random number too. So I take 4.5 and 784. 784 is equal to k upon 4.5. So now 4.5 times 784 should also be equal to this one, but it is 3528. So it is not a suitable sample. So no, as it has different k values. Question number 10. Another model of log n equal to, so that model was not satisfying, so they tried to devise another model. Log n is equal to 7.15 plus cm, where c is a constant. Complete the table for log n, correct to place one place of decimal. Log n, we can see that log 2028 was giving us 3.3. So similarly, log 57 we take, it gives you one decimal as 1.8. Log 14, one decimal should be giving you 1.1. Log 3 to one decimal should be giving you 0.3. So that is the table. Complete the scatter diagram for log n against m. Where is m? M is this one and log n is this one. So he has done for 3.5, 4, 4.5 and 5. For 5.5 we have to do. For 5.5 it is 1.8. For 5.5 it is 1.8. So it is somewhere between 1.5 and 1.2, somewhere over here. Then for 6, it is 1.1. And for 6.5, it is 0.3. That's going to be the 1. The mean is 5 and 2.2. On the diagram, draw a line of best fit, 5 and 2.2. 5 and 2.2. 5 and 2.2. That's going to be the mean. So, what is the line of best fit? So, it is going downwards. It should pass through the maximum points and to the mean. So, this is a line of best fit. Use your line of best fit to find the value of C. What is C? C is going to be the gradient. C is going to be the gradient. Change in log values upon, so C can be written as nothing but what? Change in log values upon change in M values. So C. So take any 2 points and find the gradient. So what am I going to do it out? I am going to zoom them and take any 2 perfect points, and maybe this point, and I can go through that, maybe this point. So this point is 3.5, 3.6, 3.6, 3.7, 3.8, 3.8, 3.8 and 3.7, 3.8 comma 3.7, and this point will be 6.2 comma 0.7, 6.2 comma 0.7, 6.2 comma 0.7. So the gradient is y2 minus y1 by x2 minus x1, 6.2 minus 3.8. So check that by calculator. 0.7 minus 3.7 divided by 6.2 minus 3.8. It should be something around 1 minus 1.25. I got the answer as minus 1.25. That is also okay. But the main problem is with this one is it is not the exact one, because our line of best fit is not passing to the maximum point. So what am I going to do? I am going to erase this one and try a line of best fit passing through the maximum points and the mean. So this is a line of best fit which passes through maximum points and also to the mean 5 comma 2.2. Now I try to take it out 2 points. We'll take 2 points, this point which is 4.3 comma 3, 4.3 comma 3, and maybe the 5 comma 2.2 itself only. So y2 minus y1 by x2 minus x1. So it will become, I take that one, 2.2 minus 3 divided by 5 minus 4.3. So this should be giving me around 1.1 minus 1.1. That's going to be the, what is this gradient? Minus 1.1 to 1 decimal place, correct. Now coming to question number 11. A model for the number of earthquakes in San Francisco between 1950 and 2018 is given like this. And another model where M is the magnitude, N is the number of earthquakes. There are 1013 earthquakes with a magnitude of 4. Find the difference between this actual number and the number the model predicted. So So n is equal to 10 to the power of 6.6 minus 0.91 times 4. So I calculate this value. So I take the calculator, 10 to the power of 6.6 minus 0.91 times 4. This gives you 912. So the difference is 1013 minus 912, which is 101. Use the model to estimate the number of earthquakes of any magnitude. So what should be the of any magnitude? What do I mean by any magnitude? So we will be taking it out the value of m as 0. If I take value of m as 0, then it becomes 10 to the power of 6.6, which is 398,000 in a rounded form. So I got it out. For any magnitude means, so it is should be a free of m. So m should be equal to 0. That is the reason I have taken m is equal to 0. On the diagram, sketch the graph n is equal to, for n, from 3.5 to 7.0. So what are we doing it out? We are drawing the graph for 10 to the power of 6.6 minus 0.91 times m. From m value is nothing but what? 0.3.5 to 7. So going to the Desmos and graphing 10 to the power of 6.6 minus 0.91. It should be on the top itself only, minus. So what I'll do, I'll write in the form of a bracket 6.6 minus 0.91 times x, and the x values are from 3.5 to 7. We can see that the graph is going to be, and y values, we take it out maybe from 3000. Y values is from 0 to 3000. Then we can see the graph is somewhere like this. It's coming and meeting almost at 7. So it is asked from 3.5 to 7. So when I take it out 3.5 over here and substitute 3.5 over here, 10 to the power of 6.6 minus 0.91 times 3.5, it is approximately 2600. So I take it as 2600, or you can take it as round figure as 3000. And you can see from that graph is continuously decreasing, and it's going to be in this way. And at 7, for example, when I take it as 7, it becomes very less. So I try to check the value at 10 to the power of 6.6 minus 0.91 times 7. When I go back and change the values and find it out, it should be becoming something around 1.6, means which is almost all equal to 0. So what am I going to do? I'm going to draw this graph from 3000 and almost all reaching that 7 at 0. What effect would another earthquake of magnitude 7 in this period have on the graph? So no effect. Why? Because it is almost all equal to 0. There is no effect because at 7 it is almost all equal to 0 itself only. There is no effect. So that's going to be the paper. That completes the paper. See you in the next paper. Bye.